Well guys, so welcome to the proof by integration for volume of cylinder pi r squared h. So we have to prove this using integration. But I found out that, well, the most of the videos I watched on the integration proof for volume of cylinder, they technically use a very small cylinder, the volume of the very small cylinder, to find the volume of the bigger cylinder. But here's the thing, we're just trying to find volume of a cylinder. It doesn't matter how thin or how big. So that means when they find the volume of the very small cylinder, that should be it. Because even if you say that it's so small that the base area is pi r square and this length is only dx, and then you say that the volume is integration of pi r square dx, but here technically you have just found out the volume of the cylinder, because this is technically, or this is the height of the cylinder. So in fact you do get pi r square h generally. Now I'm not saying they're wrong, maybe I am wrong, I don't know, I'm just confused, because yes, they do find the volume of the cylinder, but I found that they technically use the volume of the cylinder formula to find the volume of the cylinder, this bigger one. So let me show you what I mean, and let me show you what I also mean. So let's find the volume of cylinder first. Consider this figure, height is h, radius r, so that we have y equals to r, because in a cylinder radius does not change. Now the proof I'm going to do is using the sum of the areas. Now in a cylinder, let's take this base area of the circle, which is the top part of the circle. Its area is of course pi r square. We know that. So if we have a cylinder, right, that means there is a circle at the top and at the bottom as well. But however, inside of the cylinder there are also infinitely many of those circles. And since the radius is same, the circumference will also be the same. That means that the area of each of the circles will also be exactly the same. So if we have the area of all of these circles, the infinitely many circles, together summed up, they will in fact give the volume of the cylinder. So that means the volume of this cylinder, will be the sum of pi r square into infinitely many circles. Now let's say that this just one very thin circle occupies a space in this cylinder as dx. That means we have to sum pi r square dx. Now since dx is very small, we can put it in integration form, pi r square dx. Now these circles go from the very top of the cylinder to the bottom. So that means let's start from the bottom where the height is, well, basically 0, all the way to the top, which is height, let's say h. So 0 to h. So overall we get pi r square x h 0. Second part is 0, so we get pi r square h. That is the proof, kind of, because as you noticed, when I said that this one cylinder occupies a very small space in this cylinder, that I have transformed it into three-dimensional. I have transformed it into the volume, because here we have the area into a certain length, which is, well, area into length, which is also which is volume, which is a very small volume, but nonetheless it is in fact the volume of a very small, very thin cylinder. But what I just proved here is that the volume of the cylinder is pi r square into dx. Here pi r square is the base of the circle, base area, dx is the height. So I just proved that the volume of this thin cylinder is base into height without integration. Because before I moved on to integration, I talked about the sum of these infinitely many cylinders throughout the of the circles throughout the cylinder before even moving on to integration or summation. So technically that is not proved by integration, that is proved by logic or geometry, I guess. So but yeah, I don't know. If you guys can help me out, that would be great. And well, if you learned something new, please like and subscribe. Thank you.